Okay, welcome, Funry Rigney. I'm Susanna and Alexia and Stefani, Alexis, Adam, Antonio, and Bruno, and Diego. Thanks for coming. Let's jump into the quiz. So let's find it. Okay, so here's your quiz. And the first question is, use the method of Lagrange multipliers to find the maximum and minimum values of f of xy equals x squared plus y squared, subject to the constraint x squared plus 4 y minus 3 squared equals 4. All right, so what do we need to do? If we want to use the method of Lagrange multipliers,
Take the
what do we have?
derivatives.
Yeah, we need to take the, but in one word,
Fx.
the gradient. We want to take the gradient. Okay, so let's do it. Grad of f is equal to, and that's supposed to be easy. I hope that was easy for you. 2x comma 2y. Any questions on that?
If I didn't write gradient, is that okay? If I put capital F of x, capital F of y? I think I did the same process though.
Yeah, if you show all your work, I won't take off points.
Got it. Thank you.
GRAD is not hard to type. So that's how people write it when you don't have an equation editor. I could do this in an equation editor, but that takes a long time to do. So I'm just going to do it without. And I purposely made it so you don't really need an equation editor on this one. It looks good enough, doesn't it? Okay, and that's equal to lambda. I'm not going to use the letter lambda, too hard to type. So how about just A? Sound good? Times the gradient of G. Okay, and notice we subtract 4 from both sides to set it equal to 0, but it doesn't matter. The 4 goes away when you take derivatives. And that's going to be 2x, comma, 8 y minus 3. I use the chain rule there. Any questions on the first piece? Okay, what do I do next?
Set the constraint equal to 0.
I
don't know if it's
that's
necessary.
Actually, we already kind of did that. We already did that. I did that in my head and took a derivative, and the 4 goes away anyway. Yeah, we set each component equal to each other. So we have 2x is equal to 2ax. We also have 2y equals to 8ay minus 3. And then don't forget, we have the original constraint, which is x squared plus 4 y minus 3 squared equals 4. So I like to write it just so I don't forget about it. Which of these is the easiest to deal with? Yeah, let's call it the x, or the first equation. So can I say that the first equation tells us automatically a equals 1?
Isn't it x squared?
Which one?
The first one. I think I might have divided wrong.
Isn't what x squared?
2x divided by 2x.
Okay, what's 2x divided by 2x?
Is it 1?
Yeah, 2x divided by 2x is 1.
Yeah.
Anything divided by itself is always 1. That's a standard math thing. But you can also have x equals 0. So we have a equals 0 or a equals 1 or x equals 0. So there's really 2 choices here. There's 2 cases. And I'm going to write them on separate lines, and you'll see why in a bit. Because if a equals 1, Then we can go and work this out. Well, if a is 1, then 2y is equal to 8y minus 24. Any questions on putting a equals 1 and multiplying the 8 through? Okay, and then I can, let me just subtract 2y and add 24 and move them over. And that gives us 6y equals 24. So what's y? Not a hard question. Yeah, y is 4. So y equals 4. All right, so now we use the third equation to get x. So we have x squared, and then plus, and 4 minus 3 is 1. 1 squared is 1. 4 times 1 is 4. Isn't that nice? Plus 4 equals 4. So what's x equal to? Yeah, good news is x equals 0 anyway, but we got to worry about that. So 0, comma, and y was 4. Okay, then if x equals 0 and a is anything, that's important to note, then notice that it doesn't matter what a is because we use the second one. If x equals 0, then what is y? Well, then we get 0 squared is 0. We could divide by 4 and you get y minus 3 squared equals 1. So what's y? Y could be 4. We already got that one. What else could y be? Yeah, y could be 2. So then we also get 0, comma 2. Any questions on that? Okay, we want to find the max and min. So what do we do now? It's easy. That's a hint if you know what to do. Yeah, we plug in, but what do we? Where do we plug in? There's a lot of stuff here. Yeah, we plug into f of xy. So f of 0, comma 4 is equal to 16. And f of 0, comma 2 is equal to 4. So the minimum is 4, and the maximum is 16. The bigger one's the max, the smaller one's the minimum. Any questions on the first part? Or question 1?
Yeah,
Okay,
I tried a thing that was not mentioned here, but I'm not sure of the validity of it. I tried it a few different ways just because I was kind of confounded by the whole, the weirdness of this particular problem. But I tried, after doing more or less what you did here, also trying setting an equality of the x lambda equation and the y lambda equation to each other. So 2x over 2x equals 8ay minus 3 over 2y. And multiplying it through, I got a value of y equals 2.4, and then went from there to see what I could get.
Well, 2x over 2x is 1.
Right. But if you don't solve it through at first, you can multiply. You can cross multiply and end up with x on both sides. And
the x should still go away.
Yeah, okay.
If you got a 2x over 2x, there's no algebra you could do to get that out of to end up still having an x at the end. Because that is a 1. Does that make sense? Yeah. So
Yeah, no, I see what I did.
yeah, you might have made mistakes somewhere.
Always early morning algebra with this class.
Yeah, early morning could do things. And by the way, I got a little signal saying my internet is unstable, so I'm a little worried. I'm watching my face and I'm moving, so at least you can see me. But let me know, put in the chat box if you don't hear me or something, because that happens sometimes internet-wise. But so far, it seems like it's working. Yeah, so there's lots of places to make mistakes, especially early morning. Let's go to number 2. Number 2 is consider the function f of x, y, z equals x e to the 3y plus y cosine z, subject to constraints x squared y minus x squared z minus 3xy equals 6, and xyz squared equals 25. Write a system of 5 equations and 5 unknowns that when solved will find the global extrema of f of x, y, z, and you do not need to solve the system. So what do I have to do now?
Still take the gradient, I think.
Yeah, but I'm going to change your grammar. Still take the gradients, plural. There's 3 of them. So we need all 3 gradients. So grad f is equal to, okay, take the derivative with respect to x, you get e to the 3y. And that's it. And I guess I need my bracket. So I can say I got a vector, comma, take the derivative with respect to y, chain rule. I get 3x e to the 3y. And then plus cosine z, comma. Then I take the derivative with respect to z, which is negative y sine of z. Any questions on grad f? Okay, then I got to get grad. I'm just going to call it g. I'm just going to go alphabetical. So grad g equals derivative with respect to x is going to be 2xz. And then minus 3y. Derivative with respect to y will be negative 3x. Derivative with respect to z will be x squared. Please stop me if there's, if any of these derivatives you don't understand or what I'm doing, because I'm just assuming you get it. I can't see your faces, so I have no idea. Okay, and then let's call the third one h, just so I can write it down. Grad h equals, so this one, we have xyz squared, and the derivative with respect to x is yz squared. And then the derivative with respect to y will be xz squared. And the derivative with respect to z will be 2xyz. Yeah, 2xyz. Okay, now I put those together, and I'll do that using copy paste. That's the easiest. I get grad f is equal to a times grad g and then plus b times grad h. Okay, so notice already we have 4 variables. We have x, y, z, a, and b. So now I asked you for a system of 5 equations, 5 unknowns. What's the first equation?
E to the 3y equals lambda times 2xz minus 3y plus mu times yz squared.
Yeah, although I'm using A and B just because it's easier to type. But yeah.
Sure.
So e to the 3y equals a times, and let me just write it out, 2axz plus byz squared. Okay, and then the second one will be 3x e to the 3y plus cosine of z equals, and then we're going to have an a times 3y or 3ay. And then we're going to have a b times xz squared. And then the third one will be negative y sine of z equals, so now we're going to have an a x squared and then plus b times 2xyz. So 2b xyz. And I told you 5 equations, 5 unknowns. How do I get the other 2 equations?
They're given.
Yeah, they're given. Did I type something wrong? Let's see that second one. The third one, we have, yeah, that's actually 3x. Typo. Yeah, they're given. Those are the 2 equations. Those are the constraint equations.
Larry, in the first one, isn't it supposed to be 2axz minus 3y?
Let me find it. Oh, yeah, that's the thing. It got split up on 2 lines. So that's 2axz minus 3y. And that should be the first one. And then minus 3y. Okay. And then the last 2 I just copy down. X squared z minus 3xy equals 6. And then the second one, or the last one, is xyz squared is 25. Okay, so 5 equations, 5 unknowns. By the way, if I asked you to solve this, what would you do? Yeah, exactly. You'd give up. You would give up. Okay, so if I asked you to solve this, especially on a quiz, you would just give up and say, forget that. Okay, if you had to solve this in the real world, though, and it was your, it was your job instead of a test or something, then you would do it with a computer. Okay, and I'm not going to get into it, but there are ways of solving these things, even evil stuff like this, at least approximate solutions using computer algorithms. And that is advanced. So too hard for us to do. Any questions on this guy? Hard to finish in 20 minutes. I finished in 20, but it doesn't mean you can. Because it's 20 minutes after right now, and that included just talking about stuff. Any questions at all on this quiz? Okay, so if there's no questions on the quiz, are there any questions on anything else? There weren't a lot of questions on the homework, at least by email to me. Maybe it was an easy one, I'm not sure. Any questions? Okay. I just want to let you know, this class really is 2 pieces, more than any other class I teach. What will be on the exam tomorrow in terms of each unit we learned? The answer is nothing. There is no exam tomorrow. The exam's on Friday. So that's the first thing. There's no exam tomorrow. The exam is for Friday. And second is anything is fair game. But I did want to make sure everyone gets it, because you don't want to come to the exam at the wrong day or the wrong time. That's bad. So it is Friday, regular class time. Okay. So I'll get into the exam in a bit. But I do want to mention this class is 2 completely separate pieces. And we're done at least learning about the first piece. And that's one reason why there's 2 exams. It doesn't make sense to split it into 3 because this class is 2 pieces. And in fact, a couple years ago, when I did this class, when we had this class, not you guys, but I did in the opposite order. I did our last 6 weeks or last 6 weeks first and our first week, 6 weeks last, because it really doesn't matter. You don't need any of this stuff to do what's coming up. So just let you know that we're really at the end of this big piece, and then totally different stuff. We're mostly even done with even taking a derivative at all or an integral. We're not going to do that anymore after the exam. So that's one thing, is that this class does completely switch gears. Okay. All right. So I'll go over the syllabus, and I want to that's all I'm going to do is I'm going to show you the syllabus again, which you could do yourselves, but you probably want to see it because you're asking questions. So let me go through what we've done and talk about it, because anything is fair game from what we've done. Okay. And a lot of what we've done, not all of it, but a lot of what we've done leads to the next piece. So unlike next week, again, we're totally 2 pieces of this class. So nothing we do in this first 6 weeks has anything to do with the last 6 weeks other than the final exam. So let me just go through each of the sections and remind you. Okay. So 1.1, okay, anything is fair game. I can't give you everything, because if I gave you everything, the test would be way too long. So parametric equations. So those usually your variables t, and you're going to have an x of t and a y of t and possibly z of t. And you need to be able to find parametric equations. Okay, you should be able to graph, find, etc. Then there was calculus of parametric curves. That did have a couple equations. Who remembers the equations? What's the derivative? What's dy dx if you have parametric equations? And you remember it? I know it's been a while, but so I'm going to go through equations as we go, but basically I'm just going to go down the syllabus. So who remembers dy over dx? Yeah, it's dy over dt divided by dx over dt. Good old fractions. That's the easiest way I would like to remember it. It's just fractions. Okay. So that's parametric equations. And if you want to find an integral, again, it's just kind of standard, because the integral of f of x dy is f of, so it's, integral of f x dy is the integral of y. Integral of f of x dx is the integral of, well, f of x is y, and y is y of t, and dx is dx over dt times dt. So again, you just go by the fractions. So it's getting the integral of y of t times dx over dt. Okay, so that was another equation that you had. And then we had the length. Do you remember the length formula for parametric curves? How'd you find the length of a curve? Remember? So that was an integral from a to b of the square root of dy dt squared plus dx dt squared times dt. So that was a length formula. So those were some formulas and stuff we have with parametric curves. Then we had polar coordinates. I'm hoping you all still remember the polar coordinate formulas. What's x in polar coordinates? Yeah, r cosine theta, and y is r sine theta, and then x squared plus y squared is r squared, and then theta is the arctangent of y over x. Okay, so that happened. You should understand how to work with polar coordinates. Then there was area and arc length of polar coordinates. Who remembers the area formula? That was a special formula. It was an integral. You remember the area formula for polar coordinates? It happened. So it's the integral of, it's pretty simple actually.
It's 1/2 of the integral from a to b of r squared theta d theta.
I think you muted out after you said a to b. So it's 1/2 the integral
R
from
squared theta d theta.
Yeah. R squared theta d theta. Okay, 1/2. I like to just remember 1/2 r squared d theta. It's easier to remember that way. It's an integral of 1/2 r squared d theta. Okay, and arc length, that was the integral, if you remember, square root of 1 plus r squared, r prime squared, sorry, r prime squared d theta. So there were some equations there. Then there was vectors in a plane, and not too much to memorize there. I mean, I think you guys know how to add two vectors. I don't think there's a problem with that, and subtract. But that was, we've been doing vectors so much that hopefully you know how to do vectors in a plane. Okay, vectors in 3 dimensions. Again, that one's not too big a deal. So you can have an ijk or an xyz instead. Dot product. Hopefully you remember how to take the dot product. It's the sum of the products of the ordered terms. And then the cross product is the determinant of the matrix ijk, vector, vector. Do you remember doing those? So even if you remember doing them, I still recommend practicing each of these kind of things. So, you know, just because you think you remember doing it and you remember how to do it, that doesn't necessarily mean that you actually can. So you want to practice, practice, practice. Okay, then there were equations and lines and planes in space. And that, there were different ways of writing it. For lines in space, you can write it parametrically, x of t, y of t, z of t, and they're linear in t. Or you can have x minus something over something equals y minus something over something equals z minus something over something. And then planes, if you remember, there was a normal vector. How do you find the normal vector if you're given 3 points? How do you find the normal vector to a plane if you know 3 points on the plane? 3 non-collinear points. Okay, so you take the second minus the first, the third minus the first, and then what do you do with them? That gives you 2 vectors. When you subtract the 2 points, you, not the dot, one more guess. Not the dot product. Yeah, it's a cross product. So the cross product of 2 displacement vectors is always orthogonal to the plane. Okay, so I'm just doing highlights right now, just saying them. I'm not even writing it all out. It takes too long to write. to write everything.
Larry, couldn't you dot product and set it to 0?
That's really miserable.
Oh, okay.
Yeah. Now cross product, please, you'll run out of time on the test if you do things like that. Yeah. So it can be done, but you're going to have these big, long systems of equations. You just don't want to go there. Okay. Then you're going to have, then we went into quadratics, quadric surfaces. And let's see if you can all put in at least one example of a quadric surface, one name. Your favorite quadric surface. Or second if someone else already put it in. Okay, good. Cone. Let's hear some others. A sphere, a paraboloid. Good. There's others. A cylinder can be quadric. You can't have a paraboloid of 2 sheets, but you can have sounds like paraboloid, but it starts differently. Yeah, hyperboloid of 2 sheets. And you could also have a hyperboloid of 1 sheet. Okay, and there's one more. Which is one of the easier ones. Yeah, ellipsoid. Okay, so what you are responsible for being able to do is recognize what you've got by the equation and maybe coming up with examples. If I say, give me an example of an equation that's a cone, you should be able to do that. Okay. Then there is cylindrical and spherical coordinates. That's for 3D. Cylindrical is basically polar, but you stick on a Z. Spherical gets more complex. Remember that was x is equal to r cosine theta times the sine of phi. Y is equal to r sine theta sine phi, and z equals, x equals rho cosine theta times the sine of phi. Y equals rho times the cosine of theta times the sine of phi, and z equals rho times the cosine of phi. Okay, so you should be able to go back and forth with cylindrical and spherical coordinates. Then we moved on to functions of several variables. It's not really as much to say about the beginnings of it because it really is the next stuff that matters. That's when you had like an f of xy or f of xyz. But the important thing is you should know how to take a limit, and you should understand when a function is continuous. If you want to show a limit exists in our class, what do? There's really only one way in our class. Or you could do epsilon delta, but I don't recommend it. But what's the way we've been doing it? Yeah, polar coordinates, okay? If you want to show a limit does not exist, what do? So how do you show a limit does not exist? Yeah, you look at 2 paths, not necessarily the axes. The axes are 2 paths, but sometimes it's not the axis. Could be a parabola or something that goes to the origin. 2 paths that go to the point, such that the limit for each of the 2 paths is a different limit. And then it doesn't exist. So that's how you show a limit does not exist the easy way. There's always epsilon delta, but that's evil. So strongly recommend if I ask you to show a limit doesn't exist, not to use epsilon delta, or to show a limit does exist, same thing. It's really hard. Okay, then there are partial derivatives. I'm going to assume that you know how to find partial derivatives by now, since we've been doing it for a long time, over and over and over again, but hopefully you do. Okay, and then there were tangent planes and linear approximations. So remember, the tangent planes has its normal vector is equal to what? What's the normal vector? How do you find the normal vector of the tangent plane given a plane? given a surface. Yeah, you take the gradient and then plug in the point, and that'll give you the normal vector at that point. Okay, and then linear approximation, basically you find the tangent plane and you plug in. That's all linear approximations are. Okay, so ask questions if you have any questions, by the way. Chain rule, very important, right? Remember del, for example, del F, del, I don't know, del F, del S is equal to del F del X times del X del S plus del F del Y times del Y del F S plus del F del Z times del Z del S, or whatever variables you've got. So again, the chain rule, understand it rather than memorize it, because there's many different chain rules. So the key is to understand that if you have many variables, you break it up into pieces. And then we also had implicit differentiation. And that was, remember, that if you wanted to find, say, dz dx, then you could do it implicitly. And how do you do it implicitly? Do you remember there was a formula? So if you have a function of x, y, z equals 0, and you want to find dz dx, or del z del x, I guess, what do? Because now we're getting kind of recent. It's just a week ago. Yeah, you get negative del f del x over del f del z. Okay, would be that example. And I like to remember it as just remember the fractions work, except you got to throw a negative at you. Okay. Directional derivatives in the gradient, very important. So remember the directional derivative in the direction of a vector. First thing, you got to take that vector, make it a unit vector. And then once you've got a unit vector, so you started the v, now we have u, which is v over magnitude of v. Then you take the gradient of f and you dot it with the vector u. And that gives you the directional derivative. And then the gradient is always in the direction of maximal increase. And the opposite of the gradient, negative of the gradient, is in the direction of the maximal decrease. Any questions? Okay, then there were max-min problems. So if you want to find the max or min, what's your first step? Just for a function first. Yeah, you take the gradient of f and you set it equal to 0. What's your second step? After you solve. Yeah, you take second partial. I like to say you take the determinant of the Hessian. And the determinant of the Hessian was fxx, fyy minus fxy squared. That's the determinant of the Hessian matrix. And then plug in. And if you plug in and you get a negative number, what does that tell you? For your D. Yeah, then you have a saddle point. If you plug in, you have a positive number, are you done? Yeah, you're not done. Then you have to look at fxx of that. And if ffx is positive, it's a minimum. If fxx is negative, it's a maximum. Okay. I won't give you on a test where it test fails, because that would just be mean. But I should remind you that if you got 0 for your determinant of the Hessian, then test fails and you cry. Okay, so I'm not going to give you a test fails, by the way. So worry a lot if you take the determinant of the Hessian and you end up with 0. Meant you made a mistake. Okay, because I won't do that to you. Okay, and then Lagrange multipliers. Hopefully I don't need to talk about Lagrange multipliers since you just had a quiz on it today. But that had, a couple important equations. And that is that's what the exam covers. Will there be a problem on each one of these? What do you think? Okay, no, there can't be a problem in each one. What would happen if I gave you a problem on every one of these sections? Yeah, you wouldn't finish. That'd be like 20 questions or something like that. Okay, especially with every topic, then it's like 40 questions. And I couldn't do it. So I apologize if your favorite type is not on it. It's a pretty long test, but there's definitely not a problem on every kind of thing that happened in the class. I can't do that, but I'm not going to tell you which ones you don't have to worry about because I want you to know it all. Okay. I want you to have practiced every type. And then that way, when you get the test, you'll know how to do whatever I give you. Okay. It won't be 2 questions, but I think it's something like 13, something like that. Okay. Some are shorter. Okay. Some are short. In fact, I have a couple true falses. Those are short but hard. Okay. They don't take long, but they're, people have trouble with them sometimes. But that's what the test is going to cover. Okay. And just a note, by the way, so we take the exam on Friday, and the exam goes from 8:30 to 10:10. Okay, so it's exactly the same minutes as a regular class. There is no Zoom, so don't even try to go on a Zoom because it'll mess up your proctorio, because I'm not giving a lecture. So, and besides that, it messes proctorio. So don't go to Zoom. So what you're going to do is you're going to go down here, and you're going to see exam 1 remotely proctored. Oh, you know what? I made it due at 10:30. I gave you a little extra time. That's right. That way, because I know typing takes a little longer. So I did extend the time a little bit. Hopefully that's okay for everyone. You're always welcome to finish at 10:10, but 10:30 is when the official time is over. And then I added minutes to the practice proctorio quiz, or I added days, and I reopened it because you do need to use proctorio. And so there's a practice proctorio quiz. Let me ask you something. So see if you remember from 2 quarters ago. If you go into the quiz, you click on it, if you got proctorio set up and it says, put in your access code. What does that mean? What do you do then? So if it says, put in your access code, what do you do? Don't contact me. That's not going to help.
Try again.
Yeah, close it. Close that tab, reopen it, and try again. And sometimes you have to try 3 or 4 times. If you've never had it happen, that's great. You could smile. I'd say about maybe 25% have that. It's not student ID. There is no access code. Contacting me does nothing because I can't. All I'll do is say, hey, close it and turn it back on. And eventually it'll work. But sometimes it's just so frustrating. I hate it. And I can't do anything about it. Okay, there is no access code. But for some reason, Proctorio has a bug. And for some people, it just does it. Okay. Did you turn it on and off again? Yeah, that's all. If you email me, that's all I ask you. I won't say did you. I say also turn it on and off again, off and on again, and then it should work. Okay. I added days to the practice proctorio quiz, so you can practice again. Okay. I don't like proctorio at all, by the way, but we don't have any other system that does a monitoring thing. So you'll need to have your webcam on. And I want to remind you that most likely I don't even look at it. And I'm the only one with access. So don't worry. I'm not going to post it on some kind of, social media. It's never going to be shown to anybody. It might not even be shown to me. So I only look at the ones that I worry about. So in other words, if you're doing things that are not the way we did it in class, that's worrisome. That means you probably got help from someone else, and that's not allowed. So you're on your own. question number 1 is the same question number 1 that I put on the on the other exams from first quarter. Who remembers what that is? Yeah, basically it's promise not to cheat. And the main thing you can't communicate with anybody else, period, whether it's online, on your phone, shouldn't even touch your phone. Except children. If you happen to have a small child, then leaves my belief, children are always first. If your child needs to use the bathroom, you need to tell them it's okay to use the bathroom. Okay. And my definition of children is prepubescent. So that means, young kids that don't know calculus yet. If you want to use scratch paper, what you need to do is bring in blank paper, put it on the video screen, show it both sides, and then you can use it. Okay, but here's the thing. I will not see your scratch papers work. So don't think you're going to get partial credit or any credit for what you put on the scratch paper. Okay. The only place where you put your answers and work that if you want me to give you points is on Canvas. So what has been the best practice for this test?
Learn how to type.
In terms of technology, the quizzes. Okay, the quizzes, they look just like the quizzes. Okay, the only difference is there's Proctorio camera at you, but otherwise it's just like the quizzes. And because the camera's at you, if you're doing things that you shouldn't be doing, like listening to a video about the problem or using some kind of cheating system, then I'll know. Okay, so that's the important thing. The quizzes, other than the quizzes don't use Proctorio, are your best practice. Does that make sense? So just a note, if you want to look at the quizzes again, what can you do? Yeah, you can open them. I'm not sure if they open, but if they don't open, you can always look at them by going to the video. You can always you can always go back to the lecture videos. And remember, if you go, let me go to the syllabus again. That would be I know I put it in here somewhere. Let's see, unrelated question, content. Are we allowed to play music during a test or Proctorio detects sounds? Yeah, you can play music, but you can't talk to anyone. Yeah, you can play music, but you can't talk to anyone. And by the way, the psychology experiments show that if you don't play music during the quizzes, you shouldn't play music during the tests. They've actually done a full psychological analysis on how people do. And whatever they do when they practice and the quizzes are your best practice is what you should be doing in terms of music in the background. So if you don't have music in the background for the quizzes, it'll mess you up probably psychologically if you have music in the test, according to the psychiatrist. Just let you know that.
I just didn't want your system to be like flagging me for external sound. All right.
Well, if don't worry about the flag. Okay. If you don't have a video on and if you don't have a mic on, that's a problem. Then it'll flag you. And it's not the flag that matters. It's me seeing you cheat. And if you cheat, worry. Got it?
Got it. Thank you.
If you're not cheating, then you have nothing to worry about. Okay. As long as you're at the computer, the whole test and working it out. Does that make sense? Okay. Because I'm pretty good at knowing. And then what Proctorio does, it means I have proof. So if I have to turn you in, then I got proof that you've done it. That's what Proctorio is for. Okay. Here we go. Playlist of the webinars are right here. And you'll notice there's a lot of them. So you can go to any webinar and you can go look and you can do the quiz. Does that make sense? So I'll just randomly grab one. And there we go. Scroll. There's your quiz. And then you work on it. So if you want to go to redo the quiz, you can always redo it. And the idea is what you want to do is you want to work on the quiz. And then after you're done with this quiz, hit play again, and then you get to see if you got it right. Does that make sense as a strategy for practicing? Okay, and even though the quiz only have 1 or 2 questions, we've had a lot of quizzes. So it's they're pretty comprehensive if you look at all the quizzes. So I recommend redoing each quiz like this. And you can do it on paper, you know, and try and do it. You could do it paper and pencil, but it's better to do it either Canvas or at least do it on a, you know, some Word document or something like that. So you're used to typing. Any questions? Any questions on that? Okay, so those are the rules. And to let you know, if things go well, I'll be done on Friday grading. Okay. If things don't, if they're not perfect, then it'll be over the weekend sometime. So just let you know that I'm not a procrastinator. I tend to grade right away. That's just my style. Okay, so hopefully things go well. And hopefully no disasters happen. Okay, we actually had the very worst possible imaginable disaster on the final exam for stats last quarter. You know what the worst imaginable disaster was?
Everyone's internet crashed.
It wasn't the internet, actually. Canvas went down nationally. It was a disaster. Let's hope we don't have disasters, but I'll apologize in advance if there is one, but hopefully there's no disaster. Okay. So it didn't even matter if you had internet or not. Canvas was down. It was miserable. It's the only time it's ever gone down since I've used it. And it was right when the final exam was. And we were all crying. So let's hope that doesn't happen. But if it does, I apologize in advance. Okay, so that is, hopefully you get an idea what the test is going to be like. It's going to be like one very, very long quiz that we've been doing, except there's going to be, instead of 2 questions, you're going to have something like 13 questions. Does that make sense? And that's it. And don't forget to hit submit when you're done. And it is time to get 2 hours. So hopefully that'll work for you. So we have some time, and what I thought I'd do, if you're interested, if there is requests, there's too many to do everything, we can do some practice problems. I can make them up. I'm pretty good at making up problems. I've been teaching for decades, and math never changes. That's one good thing. Partial derivatives have never changed in my 30-something years of teaching. Only technology does. Can we do problem 4.2, which involve limits? Okay, let me, I apologize. I don't have the section numbers memorized. So let me double check what 4.2 is. Okay, limits continuity. Okay. All right, so let me give you a 4.2 question. So find the limit. Actually, let's write this down. Prove that the limit exists or does not exist. If it does exist, find the limit. Okay, now make one up. That one, yep. So the limit as x comma y, how about goes to 0, 0? And the typical ones I do have fractions. And I don't know, how about 3x squared y cubed minus xy to the 4th plus y to the fifth over 2x to the fifth plus y to the fifth plus xy let's see if I want this. Yeah, x y to the fourth. Sorry, x to the fourth y. Hopefully that'll be a good one. Okay, so I give you a warning, you know, the test, I always do the test to make sure that everything works beautifully. I'm pretty good at making the top of my head, but sometimes I make mistakes. Let's see if you can do it. I want to give you a few minutes, see if you can work this one out. So that one's the first one. I see there's other questions, but first come, first serve is what I always do. So I'll give you a minute or two. Shouldn't take too long. And when you have it, maybe you could, you don't have to put the whole solution in the chat box because that's too hard in the chat box. But maybe you can write down either it doesn't exist or it does and what the number is if it does. Let's see if two people can agree or not agree. We'll see. So again, when you've got it, say what you got. Please give me the punchline. Okay, so we got two people thinking does not exist. So if we think it does not exist, so by the way, when you look at the very first step, if you remember, is to look at it and say, is it obvious it does exist? And I'm hoping you look at this and you don't think it's obvious that it exists. So because does not exist is usually easier to show because this would be a nightmare in polar coordinates, wouldn't it? Could be done, but it would be a nightmare. So instead, let's go find a nice path to go to the origin. And I'm going to let y equals 0 because the numerator becomes beautiful first. So let y equals 0. And when you let y equals 0, then we can look at the limit as x approaches 0. And now we're plugging in y equals 0. Well, if y equals 0, there's nothing on the top left except 0. And the bottom is 2x to the 5th. What's 0 over 2x to the 5th?
Undefined.
Oh, no, it's defined. Remember, the limit as x goes to 0 means that x is not 0, but close to 0. So if x is close to 0, but not 0, what is 0 over 2x to the 5th? Yeah, it's 0. It's very defined. Does that make sense? Remember, limits are not at the point, they're near the point. Okay, so now we need to find another path. What's another path that you might want to try? Yeah, how about x equals 0? Okay, and if that doesn't work, you could try y equals x or y equals x squared. There's an infinite number of paths. So now we're going to take the limit as x goes to 0, and now the limit as y goes to 0 now. And then the numerator, if x is 0, is y to the 5th. And the denominator, if x is 0, is also y to the 5th. What's y to the 5th divided by y to the 5th? That's 1 for all y that's not 0, which means that the limit is 1. Okay, so now, since 0 is not 1, the limit does not exist. Any questions on that? Is that kind of what you were hoping to see? Okay, so there's a request for area and arc length from 1.4. Again, I have to look to see what 1.4 was because there were 2 of those kind of things. Let me go find it. So 1.4, polar coordinates. So area and arc length in polar coordinates. Okay, so those are nice. So I'm just going to write set up the integral that gives A, the area, and B, the arc length of the curve. How about of one petal of the curve y equals 4 times the cosine of 6 theta. Let's see if you can do that. So there's 2 parts because I wanted to give you the examples that you wanted, which is area and arc length. And we want 1 petal of this curve, 4 cosine 6 theta. Remember, if you have sine or cosine of a bunch of theta, then you get something that looks like a flower. So hopefully the word petal makes sense. And it's symmetric, so any of the petals will have the same area and the same arc length. So I'll give you a couple minutes. You just have to set it up. You don't have to, evaluate the integral. It can be done, but it's kind of messy. Okay, and I think the arc length is very messy. Area is not as bad. So give you a minute or two. Shouldn't take too long. Maybe 3 minutes. And again, when you've got it, I'm not looking for the number. I'm looking for the setup of the integral. Put it, at least a description of it, in the chat box. So I know that it's a good time to continue. And I do want to let you know if there are any of the quizzes that you didn't get right, I recommend redoing those first. In other words, make sure you get the stuff down. Okay, if you didn't get a quiz right, if you lost points, then those need to be, re-looked at, because that means that if I give it to you on a test, it'll be bad for you. So if you got, I'd say under 8 out of 10, that means that there was a lot of issues you had. And we've had lots of quizzes that I graded. And I also want to remind you, in case something happened to the computer, you can, if you do it right away, you can get a computer at our library for free. Okay, you just have to give it back at the end of the quarter. So I'm still waiting. Okay, at least we got an area try, and that is okay. Now remember, you have to give the limits too, from something to something. And that's another piece of it. I think I'm going to work this out, or otherwise we'll sit here all day long. And let's start out with the limits. How do you find the limits of integration, whether it's area or arc length, because it has to be done for both, and it's the same limits, or the bounds, whatever you want to call them. Okay, so this is a pedal. Now a pedal starts at the origin and ends at the origin. Does that make sense? So we can set for cosine, oops, let's try again. For cosine of 6 theta equals 0. And you need two adjacent values, and that'll get you a petal. So the smallest positive one is when our cosine of the angle, the 4 doesn't matter, you can divide it, but when the cosine of the angle, when the angle itself comes from pi over 2. So we can say first 6 theta equals pi over 2. And if 6 theta is pi over 2, then theta is pi over 12. Any questions on that so far? Okay, and that's the smallest one that's positive. What about the negative, kind of on the what it's coming from? The hint is it's pretty easy when you have cosine. Not 0, because cosine of 0 is 1. Won't give you 0. Yeah, it's just negative pi over 12. So it's either pi over 12 or negative pi over 12. How to get pi over 2? That's when cosine is 0. Cosine of pi over 2 is 0, right? Hopefully you know that, because that should be ingrained in you. Yeah, so cosine, we're setting this equal, the equation has it equal 0. And we're setting equals 0, because every time it hits the origin, you get another petal. That's how petals work with sines and cosines. All right, so in particular, we're going to have for the area for part A, we're going to have 1/2 integral from, actually, let's do it pretty, because I can. So I can have 1 over 2 and then we're going to have an integral from pi over 12 negative pi over 12, sorry, to pi over 12 of 16 cosine squared of 6 theta. D theta. Any questions on part A? Okay, for part B, I copy and paste because it's going to be the same limits of integration, at least. That doesn't change. Still in the integral from negative pi over 12 to pi over 12. But now we're not going to have 16 cosine squared of 6 theta anymore. Now, if you remember, it was the square root of 1 plus r squared. So it's the square root of 1 plus r, sorry, not r squared, r prime squared. R prime is 6 times 4, it's 24. So it's going to be 24 cosine, sine of 6 theta squared d theta. Okay, you can put the negative there if you want, but we're squaring, so you don't need it. Did I lose the r? Let's see. Oh, I think it is r plus r prime. Yep. So then I can just pop in r. Squared. Okay, and that's it. Any questions on that idea? Easy if you know what to do. If it isn't, then you'll never get it. Okay, then there was a question about quadratic. You said quadratic, but you probably meant quadric surfaces. And I'm not sure. Those are quick because there's not much there other than recognizing what they are and coming up with examples. So maybe I'll write, all right, I'll let you choose. What's your favorite example? What's your favorite quadric surface? Give me a name.
Let's do a hyperboloid.
Okay, come up with an example of a hyperboloid. Hyperboloid of, you want one or two sheets? I'll let you choose.
Two.
Two sheets.
Thank you.
See if you can come up with an example. And maybe I'll write an example of the equation for a hyperboloid of two sheets. Notice example, not general formula. So come up with an example of hyperboloid of two sheets. And shouldn't take you long, shouldn't take you more than a minute. Especially if you choose easy examples. And the funny thing is, the easiest one is the one you don't know. You don't learn until fifth quarter, winter next year. So give me an example of a hyperboloid of two sheets. Yeah, that'll work. Oh, look at that. You came up with the same example. So x squared minus y squared minus z squared equals 1. Notice this hyperboloid because if you let z equal 0, you get a hyperbola. If you let x equals 0 and or multiply by negative, let's say x equals 1, then you get a paraboloid. And that's why it's a, you get it, sorry, if you let x equals 1, you get a sphere, and that's why it's a hyperboloid. And it's two sheets because you get two negatives.
I thought you
Okay, so
wanted
we're
us
out
to
of time.
solve,
So I'm going to
I thought-
stop the share
but thank you for the
and stop
example.
the recording. And I want